this is James T. Kahn, and this is the fourth video in the libGDX 3D series that I've been putting together. In the last video, we were looking at player movement, and we set up a hard-coded position for the camera, and it wasn't very dynamic. It was just to allow us to see the character moving around. So this seems like a good time to dive a little bit more into a third-person camera, and I'll show you a quick look of what we're going to work on today. So at first, we're going to want a third-person camera that follows the slime around and is locked behind the player. A bonus feature, we'll be able to zoom in and out with our scroll wheel. And then also, if we press the tab button, we will then get a free look ability, which will allow us to move around the camera independent of the slime while still moving the slime. And then if we press tab again, toggle us back to that locked third-person camera view. So let's get started. Starting off, I wanted to mention that I learned a lot watching Thin Matrix's lightweight Java game library. And so he has a video on third-person cameras as well. And there's a lot of, you'll see once we get implemented, if you've seen that tutorial, I've learned a lot and implemented a lot from that. Of course, I had to make some modifications to get it to work with libGDX and added a couple additional features as well. And so we'll jump right into the concepts here. And one of the variables that we're going to have to add is a distance from the player, which will define how far away from the player the camera is going to be. We'll also define our pitch angle as well. And with this information, we can then figure out what the vertical distance is, how high up the camera should be based on the distance and pitch. And we will do that using the sine function, which will give us the opposite ratio, which will be this line here. And next, we will also need to figure out the horizontal distance, or the adjacent ratio. And to do that, we use cosine, which gives us the adjacent ratio. It's time for everyone's favorite part, which is getting into the code. And because I worked these tutorials out beforehand, I already know what settings we're going to need. So we'll go ahead and set those up first. And I'm going to do that by creating a new Java class, and I'll just call it settings. And because I'm a software engineer and I don't like typing the same thing over and over again, I'm going to copy and paste the settings over, but I'll have some comments here so that we understand that we'll define our camera start pitch, which is going to be our default starting pitch for the camera. And we'll have of course, we're going to have a minimum and maximum pitch so that the camera cannot go too far up or down. We'll have a zoom multiplier, so how fast our zoom will be. We'll also have a rotation around our player, so how fast will the camera rotate left and right. And we'll also have our camera minimum distance from player, so this will come into play with the zoom. How close can we get with the zoom? The next thing we're going to bring in is a enum to keep track of what camera mode that we're in. As I mentioned before, we're going to have two camera modes. One will be locked behind the player, and the other one will be a free look mode. To do that, I'm going to create a new package and name it enums. And then in that package, I will create a new enum file, and we will call that camera mode. So we'll define two modes: behind player and free look. Now that we have our prerequisites, we can get started in the main Java file, the mygdx game, and we'll get started setting up. So we had these variables from the last tutorial, but we're going to need to make some changes. So with cam pitch, we're going to head and set this to our default camera start pitch that we defined in settings. And we'll also change, so we're not going to need camera height anymore. So these are the variables that we're going to use now. First, we'll have camera mode enum, as I mentioned, for tracking our current camera mode. And we can change what we want that to default to. I think for now, let's default that to locked behind the player. We will also need, as we mentioned in the diagram at the beginning, our distance from player variable, which will be a float. And I think when I was practicing with this, 35 was a good value to start with. We also will have an angle around the player, which will default at 0. And then I'm going to have a separate angle behind player, and we'll see why when we start implementing all of this. Next up, we're going to remove this cam height from this function call here and just set it to 0, because in our update loop we're gonna keep continuously updating the camera position. So this is just a default for now. And now if we head down to our render loop, looks like we had cam height here as well. This is okay. We're about to change all of this anyways. I'm going to add a new method here for updating the camera. And let's take this logic that we did have for the camera. We'll cut it and move it into our update camera method. And from here, we're going to have a couple things we're going to need to do. So as I mentioned before, we have the horizontal distance and the vertical distance, and we need to figure that out. To do that, we can create some new functions for performing those calculations. So we will do a new function, calculate horizontal distance, and we're going to pass it the distance from player variable. And we will assign this to a float because it's going to return some information back for us. So horizontal distance. Now let's go ahead and implement this. And so if you don't know, when I put my cursor over this method, I can hit the Alt and Enter key, and then I can get an option to create a method. It's just a handy way without touching my mouse. And so for here, let me take a look at my cheat sheet. Okay, so we're going to return a float, and we'll be casting it to a float. We'll take the distance from player, and as I mentioned, we had sine and cosine depending on which ratio we're trying to figure out. And for the horizontal distance, it was the cosine, or for the adjacent. So we'll call math.cosine. And from there, we have to do one other change, which is calling this handy math to radians and passing in the our camera pitch, actually. And we'll go ahead and implement the same thing for our vertical distance. So I'm going to duplicate this line, a couple changes. All right, and the line is going to be almost exactly the same. All we really need to change here is instead of cosine for vertical, we use sine. All right, our next piece is going to be our pitch and our angle calculations. So let's create a new method for calculate pitch. And in here, we will have a couple things going on. So first off, we got to figure out our pitch change from the mouse input. And if you notice, I do have a negative sign here. So we get the, there should be a get delta, yes, get delta y. So our mouse pitch change movement. And we can times this by, I believe we had a pitch factor, did we not? We don't. We should create one though. So let's go to our settings. I'm going to add a new one here. And we'll call it camera pitch factor, which will be a multiplier for our camera pitch. And let's try 0.3 F. And we will multiply that. Okay, apparently I got some, I see. calculate pitch. Fix that method name. And so yes, so we got the pitch change. We still have this camera pitch variable, and we're going to minus equal it by the pitch change from the mouse input. And then if you remember, we have the camera, the min and maximum pitches. So we want to enforce that here. So we'll say if the cam pitch is less than the camera minimum, we'll just set it to the minimum. Else, if it's, of course, if it's greater than our max pitch, then set it to the max pitch. That should cover our calculating pitch. The next step is we need to calculate the angle around the player. So back in our update camera, we'll create another method. Calculate angle around player. And for that, we'll start looking at our camera modes a bit here, because of course the behavior will be a little bit different. If we're locking the camera behind the player, then we're not going to check for the delta movement or the X movement of the mouse and apply it. So first, let's go ahead and look at the free look mode. So we'll check if the camera mode is equal to free look. Then we will go ahead and get the angle change, or the left and right, the change from the mouse. So we'll get a float angle change. And this should be our get delta X. And we might have to create another factor here. I know, I think we do have this one. Camera angle around player factor. Yes, we do. And so we have our angle around player float that we defined, and we're going to minus equals that change. Now, that should handle it for our left and right rotations on free look. But if we're not in free look, what we're going to do here is we're going to assign angle around player to be the angle behind the player, and we'll assign that in a bit. You'll see why. But the angle behind the player is going to track. It's going to track a constant angle behind the player. So whenever the player rotates, we're always going to keep track of what that angle should be behind the player, so that if we want to switch from free look to the locked behind mode, all we got to do is use this angle behind player instead of the angle around player that we calculate here. Heading back to our update camera method, we're going to add a method. Now that we have the pitch and the angle, we're going to need to calculate the camera's position. And for that method, we're going to pass in a few variables. The current position of the player, our horizontal distance, and vertical distance. And for this next part, if you want to understand the math behind it a little bit more, I highly recommend checking out Thin Matrix's video, as it's a little more involved to explain, and I believe he explains it better than I ever would be able to. So I will leave a link in the description to his video as well, if you want to learn a little bit more the concepts behind this part. But for now, the goal is to calculate the X and Z offsets from the actual player's position. So we're calculating, we know the height, but we need to figure out where on the X and Z coordinates is the camera actually going to end up. So for that, we will define a offset X, which is going to be cast to a float. And to figure that out, we'll take the horizontal distance and multiply it. We're going to do another sine function and use our math.toRadians, passing in the angle around the player. I'm going to duplicate this line and do almost the exact same thing with one change, which is passing in or using the cosine function instead for the Z coordinates. Once we have those offsets, we can now set the camera's position. So for the X position, it's going to be the current position of the player minus that offset value for X. Then for camera position Z, it'll be the current position of the player's Z minus offset Z. And then of course we need the camera's height. Y is going to equal the player's current position dot Y plus the vertical distance that we passed in. Next up, we can get rid of this line of code here in our update camera, as the camera position is now being set in the method below. I'm going to go ahead and just start up the project to see where we're at. And so we can now rotate on the pitch, which is great. But if we move around, we're still locked. We're not, if I recall correctly, we set the default mode to be locked behind the player, so we'll finish implementing that next. And to keep track of that, so that if you remember, that was the angle behind the player. And so what we need to do to keep track of that is, well, where are we rotating the player? And that was done in our process inputs function here on our A and D keys. So what we'll do as well is update the angle behind player variable with the same values that we're doing above in the actual rotation. So for here, this should be a plus equals the rotation speed times delta time. I'm going to copy this. And for the D key, just change this to a minus equals instead for the angle behind the player. I'm going to start this back up again. Let's see where we're at. Okay, almost there. So as you can see, the camera is now following, locked behind the slime, which is great. But you can also see it's the camera itself is rotating. So the Y axis, the camera up, is changing. Now we can fix this in the camera update loop. After we've done our calculate camera positions here, we'll want to call camera up and reset the camera up to be vector 3 Y. So keep telling the camera that, hey, Y is up every frame. I play again. There we go. So now the camera's locked behind and it's staying in the correct orientation, and we have pitch. So we have our locked behind mode, and now we can look at implementing the free look mode. To implement free look, we'll want to set up a key, process and input for the tab key in this case, to change the camera mode enum, the current camera mode. So if we go down to our process inputs, let's add another line here. In this case, I'm just looking for if the key was just pressed, or the tab key. And I'm going to use a switch statement here. I like using switch statements when we have enums on the camera mode. And I'm going to let IntelliJ create these for me. So for free look, if we hit the tab button and we're currently in free look mode, we will change the camera mode to now be the behind the player. And we also will need to, at this point, we can reset the angle around player to be equal to the angle behind player, because even when we're not using the locked behind mode, we're always keeping track of that angle in these checks here, these lines. We're keeping track of this angle behind player so that we can always switch back to that when we exit free look mode. And so if we buy behind player, it's going to be very similar. We're just going to switch the mode to free look. Okay, I think let's go ahead and start it up here, and I press the tab button, and we can now look around. But you'll notice that, hey, my mouse, when my mouse leaves the window, I can't rotate anymore. And so let's take a look at what we need to do to fix that. And so part of that is the there's a method that we can call called set cursor cached, and this will work on desktop, but I do not believe it works on HTML. There are other workarounds to get this to work for HTML. I won't be going over those as I'm only focusing on desktop right now, but if you reach out in Discord, me or someone else, I'm sure we can help out. So for setting this, we'll want to do this in the create method, and what this will do is it's going to allow the window to capture the mouse so that it won't leave the window. So set cursor cached to true. Now, once that's done, once we set that, I will no longer be able to close out the window. So we also want to have a way for the player to be able to close the window still. And we can do that. We could just put that under process input as well. I'll put it at the top here. So let's do, as we do, is key just pressed. And we'll check for the escape key. We'll use that as our way for the player to close out the game. And we call GDX app exit. So if I hit escape, even though my mouse is captured, I can still get out. And let's try this again. Okay, so yep, my mouse is, you can no longer see my cursor. If I hit the tab button, I can keep rotating as much as I want. And this looks good, so I hit tab. Now what I want to do is I want to hit tab again and make sure that it snaps back to the third person, or to the locked behind mode. And it did, very good. Now to escape, I'll go ahead and hit my escape key and closes out the game. All right, we are almost done here. I think all we have left to do is implement our zoom. And to do that, we need to get the mouse scrolling information. And in libGDX, to get that information, we can't do it in the normal way. We get the mouse delta or an input. We actually have to implement this input processor interface. And what I'm going to do is I'll hit Alt Enter, and I'll get this implement methods. It makes it much easier for me. The one that we're looking for is the override for scrolled, which gives us this X and Y value. And in this case, we're going to want the Y value. And of course, with scrolling, we're going to want to change the distance from the player. So with that being said, let's get a float going for our zoom level. And that will be equal to the amount Y times our settings zoom factor. And then we can take our distance from player plus equals the zoom level. And one last constraint here. If the distance from the player is less than our minimum that we've defined, our camera min distance from player, then set distance from player to that minimum value. And then if you want, go ahead and on your end, you can go ahead and implement a maximum value as well so that you can only zoom out so far. I'll leave that up to you. And now another piece, I believe there's one other change we're going to need here. Yes, so when we implement the input processor up above, there's more to it than just that. You do have to make another function call to let libGDX know that that this class has implemented that interface and is listening for it. So in that case, we can do it right here. Our GDX input, and what we're looking for is set input processor, and we'll put this because this class is the class that implemented the input processor interface. And we had some leftover code from early on when we were using a first-person camera. And if you see, we're setting the input processor here. Well, we need to remove that because it's going to override what we have here. And so I'm just going to remove those. I don't think, we're doing a third-person camera. We can always add them back in later if we want to have a way to switch to a first-person camera. So let's run the application again and see what we have. So I'm going to use my scroll wheel. And yep, I can zoom in. only to a certain amount. So of course you'll want to adjust this. Obviously you've probably zoomed in a little too much, and then I can zoom out. If I press tab, I get my free look mode, and I'll press tab again and I'm locked back in. So that should do it for this tutorial, and let me know if it was helpful. And I'm thinking one of the next tutorials I might do is converting this code over to using the Ashley entity component framework, because the more we add in here, the longer this class is getting, the more messy the code is going to become. Let me know if that would be something you're interested in, is seeing how to convert this over to using entity component system using Ashley. Thanks.